Berlin, April 1945. A Soviet rifle squad advances through the rubble of Friedrichshain, moving from crater to crater, building to building. They approach a corner. Standard procedure. One man edges forward, rifle raised, ready to pivot and engage whatever waits on the other side. He never makes it. The burst comes from around the corner, not from a soldier leaning out, not from a weapon thrust into view, but from thin air, from an angle that should not exist. 5 rounds. The soldier drops. His squad freezes. They cannot see the shooter. The shooter cannot see them. Yet somehow, someone just fired a fully automatic weapon around a 90-degree corner without exposing a single inch of their body. The weapon that fired those rounds had a barrel that bent like a garden hose. By every law of physics and firearms design, it should not work. By every principle of metallurgy and ballistics, it should not exist. But in the spring of 1945, as the Third Reich entered its final convulsions, German engineers had produced something that defied common sense. The Krummlauf, the curved barrel, a device that let you shoot around corners like something from a science fiction nightmare. This is that story. Picture a normal STG-44 assault rifle, Germany's revolutionary Sturmgewehr, the world's first mass-produced assault rifle, a weapon that had already changed infantry combat forever. Now bolts onto its muzzle a device that looks like someone took the barrel, heated it to near melting temperature, and bent it at an absurd angle, 30 degrees, 45 degrees, 90 degrees, at a prismatic periscope sight so the shooter could actually aim. The result resembles something a child might draw if asked to design a future weapon without understanding how guns actually work. It looks ridiculous, ungainly, like someone's idea of a practical joke. It was also deadly serious. The Krummlauf represented the intersection of genuine innovation and absolute desperation. German engineers had looked at the mathematical reality of urban combat and armored warfare in 1944 and concluded that soldiers needed to shoot around corners, not lean around corners, not expose themselves, shoot around corners. The fact that this violated basic principles of barrel harmonics, gas pressure, and bullet stability did not matter. The Eastern Front was consuming men by the hundreds of thousands. Tank crews were being immolated by Soviet infantry at point-blank range. Stalingrad had taught brutal lessons about corner fighting that no one could afford to ignore. So German engineers did what German engineers did best. They solved an impossible problem anyway. Before we dive into the engineering insanity that made this weapon possible, if you're enjoying this exploration of World War II's strangest innovations, hit that subscribe button and drop a comment letting me know where in the world you're watching from. Now, let us examine why anyone thought shooting around corners was a good idea in the first place. The mathematics of corner combat are brutally simple. A soldier approaching a corner blind has perhaps a 50% chance of survival. The defender, positioned and waiting, sees the attacker first. The attacker must expose head, shoulders, and weapon to engage. That exposure takes time. 0.3 seconds, 0.5 seconds, an eternity in close combat. The defender fires first. The attacker dies. Stalingrad demonstrated this reality across months of building-to-building slaughter. Soviet and German forces learned the same lessons written in blood on every rubble-choked street. Corners were execution chambers. Doorways were fatal funnels. The side that mastered corner fighting, the side that could engage without exposure, held overwhelming advantage. Both sides tried mirrors. Both sides tried periscopes. Neither worked well. Mirrors showed you what waited around the corner but required you to lean out to shoot. Periscopes gave better angles but the same problem. To fire, you exposed yourself. The delay between seeing and shooting created its own vulnerability window. For tank crews, the problem was different but equally lethal. Soviet infantry doctrine emphasized close assault on German armor, get within grenade range, get onto the tank itself, attack vision ports, engine decks, anywhere vulnerable. German tanks from 1943 onward mounted more armor, bigger guns, better optics. None of that mattered if a Soviet soldier could sprint to the tank side and drop a magnetic mine onto the engine deck or thrust a satchel charge against the rear plate. Tank crews needed a way to engage infantry in their blind spots, the areas directly beside and behind the vehicle where the main gun could not depress and the coaxial machine gun could not traverse. German tankers tried firing pistols through vision slots. They tried hand grenades. Neither worked. What they needed was a machine gun that could fire perpendicular to the tank's hull, controlled from inside while the crew remained buttoned up and safe. The specification seemed impossible. Design a weapon attachment that would redirect automatic rifle fire by 30 to 90 degrees, maintain enough accuracy to be tactically useful, survive the gas pressures and forces involved, allow the operator to aim without exposing themselves, be manufacturable with late war German industrial capacity, not require exotic materials or impossible machining tolerances. Every firearms engineer who looked at this specification understood the problems immediately. A rifle barrel is not a pipe. It is a precision instrument where dimensional tolerances are measured in thousandths of an inch. Rifling, the spiral grooves cut into the barrel, impart stabilizing spin to the bullet. That spin keeps the bullet flying straight. Bend the barrel and you disrupt everything. The gas pressure distribution, the rifling contact, the bullet stability. The bullet would tumble. Accuracy would collapse. The barrel would fail. And yet, the requirement remained. Soviet offensives were accelerating. German cities would become battlefields. Tank losses to close assault were unsustainable. The problem could not be wished away. Someone had to solve it. The Krummlauf emerged from the drawing boards at Rheinmetall-Borsig, one of Germany's premier weapons manufacturers, working in coordination with Wehrmacht ordnance specialists. The timeline remains somewhat murky. Records from late-war German development programs are fragmentary at best, but serious development appears to have begun in 1943, with testing accelerating through 1944 and limited production beginning in late 1944 or early 1945. The engineers started with a fundamental recognition: you cannot bend a barrel while it is cold and rigid. The steel will fracture, the rifling will tear. The barrel must be heated, not to melting temperature, but close, to a point where the steel becomes plastic enough to deform without breaking. Then, locked into a bending jig, the barrel is carefully formed to the desired angle, 30 degrees, 45 degrees, 90 degrees for the most extreme variant. The barrel must cool slowly, carefully, to avoid introducing stress fractures that would cause catastrophic failure under firing pressure. The angles were not arbitrary. They represented specific tactical applications. The 30-degree variant, Krummlauf 30, allowed shooting over obstacles or pass cover while minimizing the bend and thus maximizing barrel life and accuracy. The 45-degree variant, Krummlauf 45, provided better corner shooting capability while remaining somewhat practical. The 90-degree variant, Krummlauf 90 or Krummlauf P Panzer, was the most dramatic, designed specifically for tank defense, allowing perpendicular fire from tank vision ports to engage infantry directly beside the vehicle. But bending the barrel was only the first problem. The bullet itself had to survive the journey. When a bullet enters a curved barrel section, physics become hostile. The bullet, traveling straight at high velocity, suddenly encounters a bend. The rifling continues to spin the bullet, but now centrifugal forces are pulling it outward against the barrel wall. The bullet, a jacketed lead core traveling at perhaps 700 meters per second, scrapes against the barrel's interior with enormous force. This contact strips away bullet jacket material, scores the barrel, and imparts yaw. The bullet begins to tumble rather than flying nose first. German engineers discovered through testing that bullets fired through curved barrels emerged with significant instability. The 30-degree variant produced bullets with modest yaw, enough to reduce accuracy, but not enough to cause immediate tumbling. The 45-degree variant created serious stability problems. The 90-degree variant, bullets emerged tumbling end over end. Accuracy in the conventional sense became meaningless. What mattered was creating a cone of fire in roughly the right direction. This created an unexpected tactical benefit. Tumbling bullets are devastating to human targets. They impact sideways, creating massive wound channels, far worse than stable bullets. For tank defense against infantry at ranges of 5 to 15 meters, accuracy to the centimeter was irrelevant. Hitting the general area with tumbling projectiles was sufficient. The sight system posed its own challenge. How do you aim a weapon when the barrel points 90 degrees from where you are looking? The answer? A prismatic periscope attachment. Mounted above the curved barrel section, the periscope used mirrors to redirect the sight picture. The shooter looked into the periscope, saw roughly where the barrel was pointed, and fired. At close range, the only range where the Krummlauf was viable, this was sufficient. The specifications tell the story of compromise. Barrel bend angles, 30 degree, 45 degree, 90 degree. Host weapon, STG-44, assault rifle, 7.92 by 33 mm Kurz, barrel life. Approximately 300 rounds for 30 degree variant, 150 rounds for 45 degrees variant, as few as 100 to 150 rounds for 90 degrees variant. Effective range, 10 to 20 meters depending on variant. Weight addition, approximately 0.5-0.8 Gual. Manufacturer, Rheinmetall Borsig and Contractors. Production period, late 1944 through early 1945. That barrel life number deserves emphasis. 300 rounds for the 30-degree variant. The curved section, subjected to enormous gas pressures and bullet contact forces, eroded rapidly. The rifling wore away. Cracks developed. After 300 rounds, 10 30-round magazines, the barrel became unsafe to fire. For the 90-degree tank variant, barrel life dropped to perhaps 100 rounds. 3 magazines, then replacement was mandatory. This was not a durable weapon system. This was an emergency expedient designed for situations where those 100 rounds might mean the difference between a tank crew surviving or burning alive. If you are finding this dive into German desperation engineering interesting, a quick subscribe really helps more than you know. Now, let us examine how these curved barrels were actually deployed and what variants existed. The Krummlauf program produced two main branches, infantry models and tank models, each optimized for different tactical realities. Krummlauf-wise, infantry existed primarily in 30-degree and 45-degree configurations. These were designed for street fighting, urban combat, bunker defense, situations where infantry needed to engage around corners or over barricades without full exposure. The STG-44, already a revolutionary weapon, gained the ability to fire around obstacles. The infantry version typically included a shield attachment to protect the shooter's hands and face from gas blowback, hot propellant gases venting from the curved barrel section. Even with the shield, firing the weapon was reportedly unpleasant. Gas leaked. Noise was substantial. The weapon felt unwieldy, front-heavy, and strange to handle. Production numbers are difficult to verify. Late-war German records are fragmentary, and many production runs were deliberately obfuscated or undocumented. Estimates suggest that tens of thousands of Krummlauf units may have been produced, though many never left depot storage before the war ended. The 30-degree variant appears to have been most common, representing a compromise between utility and barrel longevity. Krummlauf P Panzer represented the most extreme version, the full 90-degree bend. This variant was specifically engineered for mounting at tank vision ports. German tanks, Tigers, Panthers, Panzer IVs featured armored shutters over vision blocks that could accommodate the Krummlauf's mounting system. In theory, a tank crew member could insert the curved barrel through the vision port, lock it in place, aim via periscope, and engage infantry directly beside the tank without opening hatches or exposing themselves to counter fire. The psychological dimension mattered as much as the physical capability. Soviet tank hunting teams knew that German tanks had dead zones, areas where the crew was blind and helpless. The presence of a Krummlauf changed that calculus. The tank could potentially shoot you while you attempted to plant explosives. This uncertainty alone had tactical value, even if the weapon's actual effectiveness was limited. Distribution followed tactical priorities. Panzer variants went to armored units, particularly those deployed to the Eastern Front or anticipated urban combat zones. Infantry variants were issued to units expected to conduct building-to-building fighting, city garrison troops. Volkssturm units defending German cities in the war's final months, and some elite formations. Documentation from units that received Krummlauf equipment is sparse. The weapon arrived late in the war, when record-keeping was collapsing, units were being shattered and reformed constantly, and survival took precedence over paperwork. What evidence exists suggests mixed reception, tactical curiosity combined with skepticism about reliability. The gap between engineering concept and battlefield reality was substantial. In theory, a tank crew equipped with a Krummlauf P could engage infantry in their blind spots, preventing close assault. In practice, using the weapon required precise coordination under stress. The crew member operating the Krummlauf had to position themselves at the vision port, lock the curved barrel assembly in place, identify targets through the periscope sight, and fire-controlled bursts, all while possibly taking small arms fire against the tank's hull, with explosions nearby. With smoke and chaos everywhere, the periscope provided limited field of view. Aiming was approximate at best, and after 100 rounds, perhaps 3 or 4 engagement sequences, the barrel was spent, requiring replacement in combat conditions. Reports from tank crews who used the system in combat are fragmentary but revealing. The psychological benefit, the feeling of being able to actively defend against close assault rather than sitting helpless, was significant. Crew morale improved, but actual effectiveness in preventing Soviet tank hunting teams from destroying vehicles is much harder to document. Soviet doctrine emphasized overwhelming numbers and accepting casualties. If 3 or 4 Soviet soldiers died attempting to kill a tank, but the tank was destroyed, Soviet commanders considered this acceptable. The Krummlauf could kill several attackers. It could not stop a determined assault by a team willing to accept casualties. For infantry use, the 30-degree and 45-degree variants found occasional employment in urban combat. German units defending Berlin, Breslau, and other cities in the war's final weeks had access to some Krummlauf equipment. Soldiers used them to fire around corners, over rubble piles, past door frames, any situation where minimizing exposure meant increased survival chances. But the practical limitations quickly became apparent. The weapon was front-heavy and awkward. The sight picture was poor. Accuracy beyond point-blank range was essentially random. Barrel life meant that the weapon might fail at any moment, potentially mid-engagement, and soldiers discovered that the curved barrel assembly could be removed, returning the STG-44 to its normal and much more reliable configuration. Field reports suggest that many soldiers did exactly this. They removed the Krummlauf attachment and fought with standard weapons. There is a profound irony here. German engineers had solved an impossible problem. They made guns shoot around corners. They bent physics and metallurgy to their will. And soldiers, presented with this miracle of desperate innovation, often discarded it in favor of conventional tactics. The problem was not that the Krummlauf did not work. The problem was that it did not work well enough to justify its limitations. Better to lean around a corner with a reliable weapon than shoot around it with an unreliable one. The Krummlauf succeeded as proof of concept. It failed as practical weapon system, and that distinction matters. The Allies looked at the corner combat problem and reached different conclusions. American forces developed and fielded the M3 periscope for use with the M1 carbine and other weapons. This was exactly what it sounds like, a periscope attachment with a trigger mechanism that let the shooter aim and fire from cover. The weapon barrel remained straight. The periscope redirected the sight line. This approach avoided the Krummlauf's fundamental problems: no bent barrel, no compromised ballistics, no catastrophic barrel life issues. The M3 saw some use in Pacific theater combat, particularly in cave fighting on islands like Okinawa, but never achieved widespread adoption. Soldiers found it awkward and preferred conventional tactics. British forces relied on doctrine rather than technology. British infantry training emphasized fire and maneuver, with covering fire suppressing enemy positions, while assault elements closed distance. The British approach to corner fighting involved grenades, suppressive fire, and rapid movement rather than attempts to shoot around obstacles without exposure. This reflected deeper philosophical differences in tactical thinking. American and British doctrine generally favored speed and aggression over careful minimization of exposure. Soviet forces had perhaps the most pragmatic solution: overwhelming firepower. Soviet infantry tactics in urban combat emphasize suppression by volume, saturate the area beyond the corner with automatic fire, then rush through. PPSH-41 submachine guns with 71-round drum magazines provided the volume. Soviet tactical doctrine accepted casualties that Western armies would find intolerable. If the solution to corner fighting was to blast everything around the corner and accept that some men would die in the rush, then firepower and numbers solved the problem without requiring exotic weapons. The Germans, facing manpower constraints, material shortages, and strategic desperation, sought technological solutions to problems that doctrine and tactics might address. The Krummlauf embodied this approach: brilliant engineering applied to a problem that might not require such engineering. American M3 periscopes were simpler, more reliable, and barely used. Soviet mass tactics were brutal, costly, and effective. German curved barrels were innovative, impractical, and fascinating. There is also the question of why the Allies never captured the concept and developed their own versions. Some Krummlauf units were captured during the war's final months. Allied technical intelligence examined them. Reports exist describing the weapons and their operating principles, but no Allied nation pursued curved barrel development. The reasons appear to be tactical and practical. The Allies did not face the same desperate defensive circumstances, did not share German engineering culture's tendency toward complex solutions, and, crucially, recognized that the barrel life limitations made the weapon fundamentally unsuited for sustained combat. Understanding why the Krummlauf could never work long-term requires understanding what happens inside a gun barrel during firing. When the firing pin strikes the primer, propellant ignites inside the cartridge case. This creates an explosion, a rapid expansion of hot gases reaching pressures around 45,000 psi for the 7.92 IS 33mm Kurz round used by the STG-44. These gases accelerate the bullet down the barrel. In a straight barrel, gas pressure is evenly distributed. The bullet contacts the rifling uniformly. Wear is distributed across the entire barrel length. In a curved barrel, everything changes. The bullet enters the bend traveling at hundreds of meters per second. Centrifugal force drives it against the outer wall of the curve with enormous pressure. This creates concentrated wear on one side of the barrel. The bullet's copper jacket scrapes away, depositing material inside the barrel. The barrel's steel erodes under the combination of heat, pressure, and mechanical abrasion. Cracks develop where stress is highest. Meanwhile, the rifling, the spiral grooves that impart stabilizing spin, is being destroyed. Rifling works because the bullet's soft jacket deforms slightly, engaging the grooves. In the curve, the bullet cannot maintain consistent contact with the rifling. Spin becomes erratic. The bullet emerges with unpredictable rotation, tumbling and yawing. Gas leakage compounds the problem. Hot propellant gases seek paths of least resistance. In a bent barrel, gases leak past the bullet more easily due to the imperfect seal created by inconsistent bullet-to-rifling contact. This reduces muzzle velocity. The bullet exits slower than it should. and sprays hot gas out of any gap in the barrel assembly. This is why the infantry version needed protective shields. The 300-round barrel life for the 30-degree variant represents the point where these accumulated stresses make the barrel dangerous. The 90-degree variant's 100-round life reflects even more extreme conditions. After this threshold, the risk of catastrophic barrel failure, the barrel literally exploding during firing, becomes unacceptable. German engineers understood these limitations. The Krummlauf was designed as a consumable weapon system. Use it until the barrel fails. Replace the barrel, repeat. In the context of late 1944 Germany, with Soviet armies approaching German borders and Allied forces advancing from the west, a weapon that provided 100 rounds of angled fire might save a tank crew's life. That the barrel would then need replacement was acceptable, but this calculus only works if you have replacement barrels, if you have logistics systems to deliver them, if you have time to perform the replacement. In the chaotic final months of the war, these conditions rarely existed, so soldiers often received Krummlauf units, fired them until failure, and then had no way to restore functionality. The weapon became dead weight and was discarded. Today, the Krummlauf occupies a strange space in military history, simultaneously a footnote and a legend. Museums hold perhaps a dozen surviving examples. The Royal Armouries in the UK has one. Various German military museums display others. Collectors occasionally find them, often in poor condition, sometimes with barrels already cracked from wartime use. These physical artifacts testify to the weapon's reality. This was not a myth or a paper proposal, but actual hardware issued to actual soldiers. The weapon has found new life in video games and popular culture. Call of Duty, Battlefield, and other military shooters have featured curved barrel weapons, usually depicted as more reliable and effective than historical reality suggests. This has created a feedback loop. Young history enthusiasts encounter the weapon in games, research the real version, discover the truth is even stranger than the fiction, and the legend grows. What the Krummlauf represents depends on your perspective. To some, it embodies German engineering genius, the ability to solve impossible problems through technical innovation. To others, it represents desperation, a nation so pressed that it pursued impractical weapons rather than acknowledging strategic reality. Both interpretations contain truth. The curved barrel concept did not die in 1945. Modern military and law enforcement have developed their own versions of shooting around corners technology. The corner shot system, developed in Israel, uses a curved weapon grip with a camera and remote firing mechanism. The gun itself remains straight, but the grip bends, allowing the operator to aim and fire around corners via video feed. This solves the Krummlauf's fundamental problems by not actually bending the barrel. The bullet flies straight. Only the camera and control mechanism are repositioned. This perhaps reveals Krummlauf's ultimate lesson. The problem it tried to solve was real. The solution was ingenious, but the execution was fundamentally flawed because it fought against physics rather than working with it. German engineers bent metal when they should have bent light. If you have made it this far, you clearly appreciate deep dives into World War II's strangest weapons. Subscribe for more forgotten history and bizarre engineering. Drop a comment with where you are watching from, and let me know what other obscure World War II technology you would like to see covered next, and check out the next video in this series on next topic. Berlin, April 1945. That Soviet rifle squad, advancing through rubble, encounters fire from an impossible angle. The Krummlauf that fired those rounds represented months of engineering effort, metallurgical expertise, and manufacturing resources. It incorporated prismatic optics, precision-bent barrels, and heat treatment processes refined through extensive testing. German engineers had achieved what should not be possible: a gun that shot around corners. The barrel would last perhaps 100 rounds. This is the essential paradox of the Krummlauf. It worked. It genuinely worked. Soldiers could fire around corners, tanks could engage infantry in dead zones, and the impossible became routine. But it worked barely, briefly, and at enormous cost. The engineering triumph was real. The tactical utility was marginal. The strategic impact was nil. When the war ended, Allied forces captured Krummlauf units, examined them, wrote reports, and filed them away. No Allied nation adopted curved barrels. The concept died with the Third Reich, but it never disappeared entirely, because the problem remains. Corners are still dangerous. Exposure is still lethal, and engineers are still trying to solve the same basic problem: how to shoot at what you cannot see without being shot in return. The Krummlauf answered that question by bending metal and physics alike. It was insane. It was innovative. It was German engineering at its most desperate and ingenious. And for 100 rounds, it actually worked.